All right, we are moving on to 3.4. It says we've already seen how you can translate and reflect shapes on the coordinate grid. Today we'll explore a new transformation. So it says to the right is an example of a new transformation as well as the notation for the transformation. So take a peek at that. It says looking at the actual transformation to the right, try to identify what each part of the notation means. Note your guess for each. So the R probably means rotation, and why they didn't use the big R was because that was already used for reflection. The 50 is my guess is it is 50 degrees that it's rotating. D is talking about the point that it is rotating around, and then triangle ABC is probably talking about what is being rotated. If you go over and make an angle between A, D, and A prime, B, D, and B prime, and C, D, and C prime, and you measure them, they're all 50 degrees, which makes sense that the notation said 50 degrees. When you look at AD and DA prime, you find out that they are the same distance. DB and DB prime, DC and DC prime, they are going to be the same distance from one another. Okay. And after that, you were supposed to use your observations to come up with the definition of what a rotation is. So I said a transformation where all points rotate or spin the same number of degrees and stay the same exact distance from the point of rotation. When something, like let's say you locked hands with with a bunch of people, and then one person stayed where they were and the other people rotated around, you will always stay the same exact distance away from the person because it basically makes a circle. So if you did this, you would find that A stays the same distance no matter how many degrees it rotates, B stays the same distance no matter how many degrees it rotates, and so does C. Okay. Now you do need to know what you're rotating around, because in this problem up top, if it rotated around A, it would take a different path. If it rotated around B, it would take a different path. And if it rotated around C, it would take a different path. Beyond that, the point of rotation never moves. Okay. So what we were doing then was we wanted to try to come up with some kind of rule. While we can rotate around any point, a lot of times on the coordinate plane, you were rotating around 0, 0. So what I did was I went over and made a perpendicular line here, and I wanted to show what 90 degrees, 180, 270, and 360 looked like. So students went over and had the point 4, 2, and they went the same distance. They used a little piece of paper or a ruler or something to find the diagonal distance to get to 4, 2, and went the same distance on all the other ones. And what they found was that 4, 2 became negative 2, 4. 4, 2 became negative 4, negative 2 for 180 degrees. For 270 became 2, negative 4. And for 360, it went right back to where it was, 4, 2. And what I wanted students to do was say, instead of using numbers like a 4 and a 2, if it was an A and a B, what did we have to do? And it looked like the first one just switched what came first and second, and the thing that came first became negative. The next one, they stayed exactly how they were before, but both of them switched their sign from positive to negative or negative to positive. The next one switched, but the second one was the thing that changed from being positive to negative. If it was negative, it would have become positive. And then at 360, you don't really need to memorize this because 360 will bring you right back to where you started. So those are some rules. You should go over and memorize these rules. It basically is switch them, leave them, switch them, and then a negative goes through. So a negative first is at the first thing, then it goes to both, then it is at the last thing, and then moves its way out. So it's kind of like negatives are moving their way through the B's and A's. First it hits the first thing, then both of them, then the last thing on its way out, and then it's gone. So hopefully that makes sense. We're talking about rotations, and we have some of these rules. Now, our quick notes, a rotation is a transformation where all points stay the same distance from the point of rotation and spin the same number of degrees. We're always going to be going counterclockwise. Since it stays congruent, it's a rigid motion. We have our rules where it is flip it, so BA, then AB, then BA, then AB, and the first is, I want to call it negated. Don't call it negative, because if it's already negative, now it becomes positive. Okay, it switches its sign. Then on the second one, both of them are negated, and then the next one, just the last one is negated. So if it was negative, it's positive. If it was positive before, it's negative. Okay, check your understanding. You guys were supposed to go over and try to take the point negative 5, 2 and rotate it 90, 180, 270, and 360, and those are the locations. I always mess these up. So what I like to do is I go over and just plot the point to make sure it at least looks somewhat reasonable, like it has been rotated 90, 180, or 270. Now the next one says, after a rotation of 90 degrees, triangle ABC has KA, so it's rotating around K. The distance from K to A is 2x plus 1. KA prime is 19. What does x equal? Well, we know during a rotation, the distance to the from the point to the point of rotation always stays exactly the same. So we're able to set those things equal to one another. And the next one says, Paul, Jess, and Javier were asked to identify a transformation that took place. Paul said it was 90-degree counterclockwise rotation. Jess said that it was a translation of 9 and 1. And then Javier says that it's 270. It looks like it could be 270 or 90, but when you actually look at the primes and the non-primes, you could see that it had to actually go from the one on the left to the one on the right, which is 270 degrees. Now for your homework, circle all that are true about rotations. All points rotate the same number of degrees around the point of rotation. Yeah. All points stay the same distance away from the point of rotation. Yeah. Meaning like A and A prime will be the same distance, B and B prime will be the same distance. The image is congruent to the preimage, yes, and the orientation flips, no. Given the rotation of 75 degrees around M, triangle PTV, the angle between PM and P prime equals TM and T prime equals VM V prime, and they're all going to be exactly what the rotation was, which is 75 degrees. Okay. The next one, determine the location of the point after the desired rotation. So we have a point of negative 3, 1. We know that we're supposed to switch it and negate the first. Got it. Leave it and negate both of them. Got it. So that the negative became positive, the positive became negative. The next one was switch it and negate the second. Got it. And then lastly, 360 just ends up where it was before. Next, K is located at 5, 2. Use your understanding of the rules of 90, 180, 270, and 360 to determine how to do 450 degrees, even though that is not one of our rules. Well, if you do 450 and you take away 180s or take away 90s and just find out what the remainder is after, I did take away 360 and found out that there was 90 left. So that means it did a full circle and then it had 90 degrees left. So really I could just use the rule for 90 degrees. 450 is just 90 degrees. The next one says use the same rules, but now instead of going 90 clockwise, how do I go counterclockwise? How do I go clockwise by 90? Clockwise by 90 is actually counterclockwise by 270, and the rule of 270 is going to be flip it and negate the second one. So we flipped it and negated the second one. It becomes 8, negative 5. If this was a quiz, I would have gone over and made an ugly graph and just checked if it looked like it made sense. And then right here, just to review, you are reflecting over the vertical line that goes through the x-axis at 2. So any points on the left go to the right, any points on the right go to the left, and the same exact distance away from the line of reflection. All right, hopefully that made sense. Thanks for watching.